Hello everyone, this is Shanmukesh from FastAPI University. Currently, I am pursuing CSc in Artificial Intelligence and Machine Learning. I am very excited to share you my implementation of semantic search task given by Trademarkia. So let's start my presentation. So here is a small demo about me. I am Shanmukesh. I am actually an AI/ML enthusiastic. Currently, I have done a lots of projects on computer vision tasks like face detection. I have started these computer vision tasks a long back ago, face detection, and I have written couple of research papers, and I have also have a good domain knowledge on web development. So I have kind of doing both of the things: computer vision, artificial intelligence, and some research purpose and web development along with it. So this is actually my portfolio. So here you can see all of my activities, like from starting year onwards what I have done. There are more than 50 activities currently I have bookmarked in here. Let's come to the task. So this is the problem statement that we have received. So the problem statement was take the dataset 20 Newsgroups dataset, and there you have to do three main important tasks. The first thing that we have to do in the given task is fuzzy classification and semantic catch layer and semantic catch mechanism, and at last we need to implement FastAPI services. So here are the three things we will discuss with detailed code later on. So let me just show you my coding part. So I have written all the code with the help of web coding tools and my own knowledge. So let's explore these things. So first, run pipeline. Okay, let me just go through the overview of this. So instead of showing everything, I will just show you the overview of each and every. So code base architecture, this is my current architecture scripts and the actual files that where the code exists, the part 1, part 2 according to this task they have categorized, and the Docker file. So this is a two-phase architecture. The membership matrix is very important. In the K means so this is my architecture. In this architecture, I have the API.py is for API calls and all. So I have mentioned everything clearly. So let's move to. This is the readme file. These are the instructions that one should follow while installing on their computer. So this is a very straightforward installation. You just clone the repository and go to the trademarkia directory cd and just run the docker image build, so that you will run whole directly. It almost take 15 minutes for the first time. If you are running in a CPU and you have a good internet connection, manually want to run without docker, these things are quite helpful. So I have conda environment in my personal computer, so I use conda to install everything and to run on it. So that's it. So let's start the execution and show you. So let's start the working model of our code, like how the UI is designed and how everything is categorized. I will explain each and every point clearly. This may take a while to load and all. You should also copy the same link and open the document part of our API keys. This is a predefined. I have not written any code for this. This comes by default. It shows the how the architecture is maintained and all. So as usual, we have implemented our API keys with post, get, delete. So there is also one more thing, that is health. I think this is the health thing, which checks whether the API keys are working perfectly or not, and there is no harm in executing the delete command now. It will actually clear all the cache which is saved in our semantic cache memory. So I just want to you make you guys feel comfort with these things. So the post request, basically I need to show you UI before starting with that. So our corpus is the 20 news groups data set. So let's ask a question. I The architecture on which we have deployed is O of n. It will take O of n time, so it grows as big as our corpus is. The time to access a particular document will be O of n times. UI and about World War II. So this is also from related to cluster 3 bucket, and here also you can see all the relevant documents inside it. Let me, so these are mostly politics, right? So if I search politics on, so I think we have to configure in this post command the threshold. So here I have set the default threshold as 1, but let us decrease that threshold to somewhat a lesser value, so 0.7. And we have declared 0.85 as an optimal threshold. I will also show you how we have declared it. So if I declare that thing as a 0.7 threshold and search for a strings politics information on wars, much as data as possible from here onwards, so that the chance of getting our relevance bucket is quite quicker. So here we got a catch hit because the politics on world was we have previously searched for it. So whenever we search a new query, it will show us some kind of similarity score, and along with the similarity query that we have used previously, and it will show the relevant information according to that. And I think here only we should be able to see the relevant information. So yeah, this is the relevant result that we have got. Let me show you the threshold, how I have calculated 0.85 as a optimal threshold. So let's go to our code and run our one more file. So with this file running, we can able to see the threshold, different threshold, and how they are performance. So these are our results. Here you can see the at threshold 0.74 we have got 2 hits and 3 misses, and 0.74 and so on. So by this we have concluded that at 0. Okay, at 0.8 the threshold is good. So there we have deleted the unnecessary things, and we have extracted the only a few things which are more detailed for us. So in that way we have, so that's it guys. Thank you for giving this wonderful opportunity, and I look forward for your response.